Hi, we now begin with our discussion on the second part of Applied Corporate Finance under Unit 2. And in this, we're going to kind of continue with our discussion on the first principles and then take it ahead to our idea of how do we identify what is the minimum acceptable return on any kind of a project, right? In other words, we're going to discuss about what is going to be the hurdle rate. So let's look at broadly how we are going to define this entire spectrum of discussion that we're going to have. We're going to first define what is risk and look at risk versus return and understand how they are both the same sides of the same coin. Uh, we will understand that if they are sides of the same coin, then we can use something like a risk return model in order to identify what is the minimum acceptable return for any kind of a project or investment. And then we will get into details about the capital asset pricing model and look at the components that capital asset pricing model has. We will use that as the risk return model that will give us the hurdle rate and the numbers around the hurdle rate as we go along, right? So that's the broad contour of how we are going to look at it. If we go back to the first principles that we had looked at in order to maximize the value of the business, we are going to now cover this portion, which is that the hurdle rate should reflect the riskiness of the investment and the mix of debt and equity used to fund it, essentially. So we are now trying to identify what is the rate at which we will basically discount the cash flows that a particular project basically generates, right? So that's broadly in a nutshell what is going to get covered in this particular video. We will start with our concept of understanding what is risk and then build on that as we go along, right? So the first question that would come to our mind is why do we need a hurdle rate? Now, a hurdle rate is, as we said, the minimum acceptable return, right? So anything above this is fine, but anything below this will be a problem, right? Now we live in a world of finite resources, money, resources, everything else is kind of finite. It'll end at some point, right? So you have to allocate those resources, and hence it is important for us to get an understanding on what investment choices give us the best possible returns, right? It is important for us to understand how do we get the best possible returns in a world where resources are kind of finite. The hurdle should be higher for riskier projects. So effectively, if I'm taking a more risky project, then I should possibly be expecting a slightly higher return. That's logical, right? If there are two factories that are available in the city, but one has a chance of failing because of technology being older, then let's say you have a factory A and you have a factory B, and this is a riskier factory. And let's say my output from both of them can be 100 crore. Then whatever I'm willing to pay for B, let's say I'm willing to pay 20 crore for B. Then for A, my either if I pay 20 crore for A, I would expect more than 100 crore because I have a better choice in terms of a less risky factory which is available, or I will be willing to pay lesser for A, in which case my return becomes 10 invested to get 100 as compared to 20 invested to get 100, right? So in a sense, because A is riskier, I am looking at a higher hurdle rate here. I would want a higher return. Higher return can be found either by investing less or by expecting it to give me more. Maybe it gives me 150, right? In simple words, if we can get a certain rate of return without taking any risk, right, we should be demanding an additional non-zero rate of return for any risk that we are taking, which basically boils it down to a simple equation that a hurdle rate should be some return which we